Welcome to Maths for All. This is Higher Level Maths with Aisling Flynn. This is the construction of the square root of 2 and square root of 3 and some more, and marking them on the number line. Now, where to begin? We start with a right angle triangle with sides 1 and 1, which gives a hypotenuse of root 2 by Pythagoras' theorem. Then construct a number line nicely spaced from about 0 up to 3. So the first part of the construction is to start at 0 and to mark out the sides of the triangle. So the first one, the horizontal one, will be from 0 to 1. Then use a protractor or a set square to create the 90-degree angle for the other side of the triangle. Then in constructions we use a compass to measure equal distances. So we'll measure out the length of 1 unit using the compass. That's from the number line. And then we'll measure that equal distance on the horizontal side. Of course, you could use the boxes also. Okay, so we've got the horizontal and the vertical sides. Now, by completing the right angle triangle, we'll get the hypotenuse, and that hypotenuse should be equal to root 2. Okay, now to mark that on the number line, again we'll use the compass to measure out the distance. So starting at 0, the length of the hypotenuse is root 2, and then from 0 mark an equal length down the number line, and that will tell you where root 2 falls. Okay, and if you consult your calculator, you'll see that root 2 is equal to 1.41, and it continues because it's irrational, and you'll see that that's about right. It's some way before 1.5. Now we're going to build on that to construct root 3, and we're going to use this little triangle here, this right angle triangle, by Pythagoras' theorem. Root 3 squared should be equal to root 2 squared plus 1 squared in a right angle triangle, and that's true because 3 equals 2 plus 1. And we're going to use the base of the triangle, root 2. It will be the line that we've already constructed on the graph. Okay, so there's our triangle, and there's the root 2 that will be the base of the triangle. So first thing we've got to construct is the 90-degree angle, and you can do that using your protractor and or a set square. Okay, now we've got to measure a distance of 1 unit along that new line. So 1 unit was there, or indeed from the horizontal as well. Now strike an arc that's 1 unit along the arm of the angle. That's 1, and complete the right angle triangle, and that will give you a hypotenuse of root 3. And lastly, to mark that on the number line itself, use the compass to measure out the distance and mark an equal distance along the number line itself. And there we get root 3. And that's about right, given that if you consult your calculator, root 3 is 1.73 and it continues as it's irrational. So that's 1.246 and it's just before 1.8. Okay, so it's good as far as our construction goes. And you can continue that process to construct more roots. Here we see root 4 using this right angle triangle and using root 3 here as the base, constructing 90 degrees, and the hypotenuse will be equal to root 4. Of course, root 4 is equal to 2, so a good test of your construction would be put the point of your compass at 0 and strike an arc around, and hopefully you should land at 2. You can continue to root 5 in the same manner. Okay, and indeed 6, each of the sides of the right angle triangle being 1 the whole way around. And you can continue that process indefinitely. And what you'll end up with is something called the spiral of Theodorus. It's also called Pythagorean spiral or Einstein spiral. And here we go to the square root of 17. You can continue, but then you'll overlap the other ones. So this stopped here to make it look nice and clear.